So this week we're going to look at intro to logarithmic equations. So similar to what we did last week with exponential equations, we're going to be solving equations this week that have the word log in them or natural log, that ln. We're still going to be doing what we did last time. If you have the same base, we're going to be able to set our inner part of our logs equal and solve for x, really similar to what we did last week. So our directions say solve each of the following logarithmic equations to determine the value of x. So first one says log base 3 of x is equal to log base 3 of 5. So if we look here, they have the same base. Both of our bases are 3. So we're going to be able to set that inner part, x, equal to 5. And that first one's pretty quick. Nothing to solve there. We make our equation x equals 5, tells us our answer. X has to be 5 to make that true. So if they have the same base, we set that inner part equal and we solve out our equation. Number 2 will be a little bit harder, still not too bad, but number 2 says log base 5 of x plus 1 is equal to log base 5 of 10. First thing we just check, both our bases are 5 here. So we're going to be able to set our x plus 1 equal to 10 and then solve that equation. So our equation for number 2, x plus 1 equals 10. That's a one-stepper. Subtract 1 from both sides. X should be 9. So for number 2, our final answer is just x equals 9. So if they have the same base, we set them equal. Make our equation and then just solve it out like we did last week. The only difference from last week is that we're looking at logarithmic equations this week instead of exponential equations. Number 3 and 4 are similar to 1 and 2, but they get a little bit more complicated, a couple more steps. First thing we check for number 3, log base 2 of 2x minus 4 is equal to log base 2 of 8. Both of our bases are 2. So we can set the 2x minus 4 here equal to 8, and that'll be our equation to solve for number 2, or number 3. So 2x minus 4 equals 8. That one's going to take 2 steps. So we want to get x by itself, add 4 to both sides, 2x equals 12. And then our last step, remember you want to divide to get x by itself now. So to get rid of that 2, we're going to divide both sides by 2. And if you worked ahead on this one, you should have got that x was 6. Number 4, same thought process. We have log of x equals log of 2x minus 5. Whenever you just have the word log, your base that you don't see right here is a 10. So it's really saying log base 10 of x is equal to log base 10 of 2x minus 5. So we're going to set x equal to 2x minus 5 this time. So our equation looks like that. X equals 2x minus 5. You have x's on both sides of your equation this time, so we want to get them all on one side. So we can move that 2x over by subtracting it, and that'll give us negative x is equal to negative 5. So remember, whenever you have a negative variable, there's one more step you have to do to finish that equation. So to get x to be positive, we're really dividing both sides by negative 1. So if you worked ahead on number 4, make sure that your final answer is actually x equals positive 5. So don't forget that last step on number 4, you had to divide both sides by negative 1. All right, we got 2 more examples to look at that are similar to the first 4. So number 5 says ln of 3x plus 4 equals ln of 5x minus 8. Remember that ln just stands for natural log. So it's just saying log base e. So if you see ln in your equation, it's still done the same way. They both are natural logs, so we can set 3x plus 4 equal to 5x minus 8. That's our equation to solve if you want to work ahead and see if you get the same answer. I decided to subtract 3x from both sides first. It's okay if you started a different way, just make sure your answer checks out at the end. So that gave us 4 equals 2x minus 8. Now we want to get x by itself completely. Add 8 to both sides. So we get 12 equals 2x. And then your last step there, you have a 2 attached to your x. Remember, that's multiplying. So to get x completely by itself, you have to do the inverse operation and divide by 2. So our final answer for number 5, if you worked ahead, you should get x is 6 or 6 equals x. Either way, it's just telling you x is 6. So it doesn't matter if your equation ends with x equals 6 or 6 equals x. Just make sure if you worked ahead, you got that same answer there. And then our last one, we have log base 7 of 2x minus 6 equals log base 7 of 5x minus 12. Check first, they have the same base of 7, so we can set 2x minus 6 equal to 5x minus 12 and solve it out. So that's our equation for number 6. I decided to subtract 5x from both sides first. If you decided to move the 2x or the negative 6 or the negative 12 first, just make sure you get the same answer at the end. So we get negative 3x minus 6 equals negative 12. Add 6 to both sides. Be careful. If you aren't too sure about your mental math facts when you have a negative, go ahead and throw that in Desmos or your calculator. Negative 12 plus 6 will give us negative 6 on the right. So our equation looks like negative 3x equals negative 6 now. And then you're going to divide both sides by negative 3 at the end. So x should be positive 2 for number 6. So just be careful with those negatives. If you worked ahead, make sure you got positive 2 as your final answer for number 6. When you divide a negative by a negative, it turns positive. So just to recap really quick, check your basis. If the log has the same base, set that inner part equal to each other to make your equation, kind of like what we did last week with our exponents, and then you're just solving it out. I would grab some scrap paper for the ones that take more than 1 or 2 steps. That way you can write them out and make sure that you don't rush and get it wrong. But we're still just solving some equations this week. We're just solving log instead of exponential. So slow it down, watch it again. Use the notes that are filled in to help you when you're doing your practice. And good luck.